Welcome to another podcast from George Eastman House, International Museum of Photography and Film.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth.
This is in the middle of the 60s. This is when the Cold War was in full flourish. It's as if by President Kennedy making the statement, "We will put a man on the moon." It's really staking the reputation of the U.S. government, the U.S. military, against the Russians, which, at the time they considered them to be the evil empire.
We go into space because whatever mankind must undertake, free men must fully share.
It's no holes barred. We're doing this. My name is Todd Gustafson. I'm curator of the technology collection at George Eastman House. We're in the gallery today to look at the Lunar Orbiter, which is a satellite that contained a camera module. It was designed by Eastman Kodak Company. And what they wanted to do was to come up with a system that could map the surface of the moon. And this was for the Apollo project. They were looking for a nice flat spot to land, and so they had to design a rather complicated camera to work in space to do that. And if you look historically at the way this project panned out, NASA was way behind the Russians. In 1961, didn't even have a rocket that could get off the ground successfully on a dependable basis. So, 6 years later, we have this satellite which they're able to control remotely from Earth, sort of like in a real simple way, controlling a radio-controlled airplane, if you would. So, it's pretty amazing. And to realize what had to be done is you've got to come up with a camera that can expose and process the film, and then you've got to get the image back, which they would actually scan the film, and this is 1966, and then would transmit those images back to NASA. So it's a pretty complicated task, and they succeeded. They built enough parts to build 10 orbiters. You've got to realize that this is a rocket. It's likely going to blow up or could blow up. So they actually used 5 or 6 of them, depending on who you talk to. They built enough to make about 7. This was going to be the 7th fly model, which was not used. And basically, again, you're looking at a device that was unmanned, sort of remote controlled from Earth. They wanted to get specific areas of the moon photographed. They actually ended up mapping the entire surface of the moon. In fact, the process or the project was so successful, they ended up doing some sort of art images, if you would, to sort of sell the project. And basically, again, the orbiter would photograph the moon in strips. It's a scanning camera, meaning it's going to, per orbit, is going to take a little strip at a time. The film was processed in the orbiter. Used something called BIMAT system, which is, to kind of really simplify it, sort of a Polaroid kind of thing. And then the images would be scanned. It was an analog scanner. The images would be sent back to NASA. They would receive them. So you basically are looking at something that's really akin to a flying television station and photographic mini lab. Well, the first thing you run into when you look at this thing is you figure this is going to weigh a lot. It weighs about 35 pounds. It's welded titanium tubing. It's very light. It was designed to fly in space. The other thing that's really kind of interesting is if you look on there are 2 lenses on the front. If you look on the bigger one, it's a telephoto lens. There's a little gizmo in the center. That's actually a defroster. So they had to account for the fact that they're going to have a hot and a cold situation. The lens is going to steam up. When I say hot and cold, they actually had to raise the temperature quite a bit when they process the film in the orbiter. So they've got to account for the steam, if you would, on the lens. So all these little details were taken care of. You realize you're actually photographing a moving body from a moving body, so you've got to account for that. And it's also designed to take quite a bit of shock. If you launch something into space, there's a lot of G-force on that, and it worked. And it worked very, very well, actually. Go through the various parts here. First of all, this little black ball in front, that's actually the climate control system. That's actually what's responsible for raising and lowering the temperature of the orbiter. We have a wide-angle lens and a telephoto lens. We have something called the V/H. This is the gizmo that actually keeps track of the moving bodies, so you get them photographed properly, so you're going to have a correct representative size space thing. We have a film supply mechanism over here. The back end of it is where the film is scanned. In fact, the scanner is in the very back, right back here. So yeah, just a general amazing, caffoonery of parts. welded titanium tubing, also that space-age material called Velcro. There was a heat shield blanket that was held in place by Velcro. Just an amazing, amazing bit of technology for the time. And it's you got one chance. It's a lot invested in this, so very, very complicated thing. And again, they worked actually much better than NASA had really planned on it. So.
Now it is time to take longer strides. Time for a great new American enterprise. Time for this nation to take a clearly leading role in space achievement, which in many ways may hold the key to our future on Earth.
We hope you've enjoyed this Eastman House podcast, and if you'd like to find out more, visit us at eastmanhouse.org. This Eastman House podcast is made possible by the generous support of Midtown Athletic Clubs, a leader in upscale athletic and sports resort management with facilities throughout the U.S. and Canada. Visit us at midtownclubs.com.